Hello, my friends. In this episode, we will move a step deeper and explore another famous question: wave-particle duality. Electrons and photons sometimes behave like waves, and at other time like particles. For a long time, this has been considered one of the most strange features of quantum mechanics. Many explanations focus mainly on the technical details. But if we look at the issue from a more fundamental philosophical perspective, we may arrive at a more unified and clearer understanding. In the next few episodes, I will try to present the core ideas behind quantum mechanics in a very condensed way, while also proposing a new angle for understanding them, even solve these mysteries. Some friends might feel that this sounds a little bit exaggerated. After all, quantum mechanics is often regarded as one of the most complex scientific theories in human history. How could its mysteries possibly be unlocked in just a few episodes? Yet, as we discussed in the previous episodes, science never exists in isolation. It is always grounded in philosophy. When a scientific theory reaches a certain explanatory limit, what we often need is not more complicated mathematics, but the willingness to step back and reconsider the philosophical assumptions that we have taken for granted. With this in mind, this series will attempt to approach quantum mechanics from a different perspective. We will not avoid the depth of these questions, but neither will we mystify them. Instead, we will carefully unpack this seemingly puzzling phenomena step by step and see whether, by changing the way we think, the quantum world might become clearer than we once imagined. I hope you will join me as we continue this journey of exploration together. And please subscribe my channel, leave comments, and share your thoughts. I look forward to hearing your voice. Among all the mysteries of quantum mechanics, wave-particle duality is perhaps the most widely known and one of the most puzzling. From an early age, our intuition about the world seems clear. Things are either particles or waves. Particles are localized and identifiable, like tiny balls that occupy a specific position. Waves, on the other hand, are spread out and continuous, like ripples moving across the surface of water. Conceptually, these two categories appear fundamentally different, even mutually exclusive. Yet, when we enter the microscopic world, this seemingly clear distinction suddenly collapses. The same electron, under different experimental conditions, can display completely different characteristics. Sometimes it behaves like a wave, producing interference and diffraction. And other times it behaves like a particle, leaving discrete, localized impacts on the detector. Naturally, people are led to ask what seems like a responsible question. Is an electron a wave, or is it a particle? However, as we have repeatedly emphasized, this question may itself rest on a hidden assumption that objects must possess fixed properties independent of observers and relationships. In the worldview of classical physics, objects are thought to have definite attributes, such as precision, velocity, and shape, that belong to them intrinsically. But the phenomena revealed by quantum mechanics seem to challenge this assumption again and again. From the perspective of relational non-duality, we can approach the problem differently. Relational non-duality proposes that the world is not composed of completely independent entities, but rather of a network of relationships. The properties we experience are not intrinsic attributes of isolated objects. Instead, they are experiential manifestations that arise within the relationship between subject and object. In everyday experience, this idea is actually quite familiar. For instance, sound is not simply the vibration of air itself. Air vibrations are merely physical processes. What we call sound emerges when those vibrations enter into relationship with a hearing system. Similarly, color is not a property of light alone, but a manifestation arising in the interaction between light and the visual system. In other words, many things we treat as properties of objects are in fact experiential phenomena emergent from relationships. If we apply this insight to quantum mechanics, wave-particle duality can be understood in a new way. Instead of asking, is the electron a wave or a particle? The deeper question becomes, within what kind of relational structure does it manifest as a wave? And within what kind of relational structure does it manifest as a particle? When a quantum system enters a particular relationship with an experimental apparatus, for example, in a double-slit experiment, if no measurement is made to determine which path the particle takes, the system produces an interference pattern. Mathematically, this state is described by the wave function, which represents a distribution of probabilities or possibilities. Under such conditions, the system displays typical wave-like behavior. Yet, from the perspective of relational non-duality, this wave is not the object's true form. Rather, it is the manifestation of a relational structure described through experience and mathematics. The wave represents an unfolding network of possible relationships. On the other hand, when we perform a measurement, for example, when a detector records the position of an electron, we obtain a definite, localized event. The electron is detected as a particular point. We then say that the electron behaves like a particle. But even this particle-like character does not need to be understood as an intrinsic form of the object. Instead, it can be seen as an experiential event that appears when a definite relationship forms between the subject, the measurement apparatus, and the quantum system. Particle-like behavior is not the essence of the object. It is the experiential result that arises once a relationship becomes determinate. From the perspective of relational non-duality, therefore, wave-particle duality does not mean that the object possesses two contradictory properties. Rather, it reflects two experiential manifestations arising from two different relational structures. Under certain relational conditions, the system appears as a wave-like probability structure. Under other relational conditions, it appears as a localized particle event. Wave and particle are not opposing ontological forms, but two different expressions of a relational network and the level of experience. It is precisely through this understanding that in the last episode we addressed the so-called observer effect. Traditional explanations often make it seem as if the observer changes reality. But from the perspective of relational non-duality, observation does not mysteriously alter the objective world. Instead, observation establishes a new relational structure. When that relational structure changes, the mode of experiential manifestation changes as well. So the system appears to shift from wave-like behavior to particle-like behavior. If wave-particle duality seems puzzling, it is largely because we insist on asking, what is the electron in itself? The first step taken by relational non-duality is not to propose a new physical model, but to redirect the question itself. What we truly need to let go of is the assumption that the electron is a fixed entity existing independently of relationships. Existence is a manifestation within a relational field. Wave and particle are simply forms arising within different relational structures. When we move from entity-based thinking to relational thinking, quantum mechanics no longer appears as a challenge to reason. Instead, it becomes a mirror. It reflects an assumption we have long taken for granted. The way of thinking that splits the world into subject and object and fixed properties within isolated things. What ultimately needs to change is not the physical theory itself, but the way we understand existence. My friend, if you find these questions interesting, feel free to subscribe my channel. Here we explore philosophy, science, and how these ideas can be applied in real life to cultivate a more thoughtful and positive way of living. I would also love to hear your thoughts, so please leave comments and join the discussion. If you enjoy my channel, your support and subscription are greatly appreciated. Let's continue this journey of exploration together. In our previous discussion, we saw that perhaps the more important question is not to ask what exactly is the electron, but rather to understand under what kind of relational structure it manifests in what kind of form. And yet, even so, human thinking seems always compelled to go one step further. We are not only interested in how phenomena appear, we also instinctively want to know, what is existence itself? For this reason, many people, after understanding the idea that relations determine manifestations, still feel driven to ask a deeper question. If wave and particle are merely forms of manifestation, then behind these manifestations, what is the electron itself? What is its true nature? Okay, let's figure it out then. Actually, in a certain sense, saying that the electron is both wave and particle does not seem entirely wrong, because it does indeed exhibit both patterns of behavior. However, if we press further and ask, what is the electron in itself? The problem becomes much more complicated. The concepts of wave and particle both originate in classical physics. In classical physics, a wave is a vibration that spreads continuously through space, like ripples on water or sound waves in the air. A particle, by contrast, is a localized entity with a definite precision and trajectory, like a tiny ball. But quantum objects do not truly fit either of these classical categories. If the electron were truly a wave, it should spread continuously through space like a water wave, and every measurement should reveal that same extended structure. Yet what we actually observe are discrete detection events. If the electron were truly a particle, then in the double slit experiment, it should pass through one slit like a tiny ball and produce two simple clusters on the screen, rather than forming an interference pattern. It is precisely here that we begin to realize that the concepts of wave and particle may be nothing more than the linguistic tools we use to describe experiential phenomena, rather than faithful representations of the true nature of the microscopic world. Therefore, in a deeper sense, the electron is neither a wave nor a particle. Wave and particle are not two ontological forms belonging to the electron itself. Rather, they are two different modes of experience that arise within relationships. The wave describes an unfolding of possible relations, a holistic structure before determination occurs, while the particle describes the localized event that appears once the relationship becomes definite through measurement. Once we recognize this, we are no longer dealing merely with a problem in physics. At this point, we are facing a philosophical question. When something can neither be fully described as a wave nor as a particle, how should we understand its true nature? Throughout the history of philosophy, when confronted with such difficulties, human thought has developed different approaches. One important tradition is the use of negation to point towards the deeper nature of reality. This method is particularly evident in Buddhist philosophy. For example, in the Madhyamaka tradition, philosophers often analyze things using a form of reasoning that says, it is neither this nor that. It is neither absolute existence nor complete non-existence. By repeatedly negating conceptual boundaries, philosophers attempt to reveal an important insight: that the true nature of existence cannot be fully captured by simple concepts. Language and concepts are tools, but when we try to confine ultimate reality within them, they often prove inadequate and even misleading. From this perspective, when we say that the electron is neither a wave nor a particle, the statement carries a similar philosophical meaning. It does not deny the existence of the electron. Rather, it reminds us the wave and the particle are simply two descriptive frameworks within our conceptual system, while reality itself may transcend these categories. In other words, our language and theories attempt to grasp reality, but reality itself does not necessarily conform to the boundaries of our concepts. Yet, philosophy does not offer only one path. Alongside this method of negation, which emphasizes the transcendence of concepts, there is another approach. Instead of rejecting conceptual descriptions entirely, it seeks a more inclusive relationship between appearance and essence. For instance, in more traditional Vedanta philosophy, there is the idea of neither identical nor different. And that is the true spirit of non-duality. According to this view, reality cannot simply be said to be identical with phenomena, but neither can it be said to be completely separate from them. Essence and appearance are not absolutely divided. Rather, they are connected in a subtle and profound way. Phenomena do not completely conceal reality. In some sense, they are expressions or manifestations of it. Seen from this perspective, wave and particle need not be regarded as misunderstandings of reality. Instead, they can be understood as two ways in which reality manifests within different relational structures. They are different aspects through which reality reveals itself under particular conditions. Thus, we find ourselves facing a deeper philosophical choice. When reality exceeds the limits of our conceptual frameworks, should we point towards an ineffable essence by negating all concepts? Or should we adopt a more inclusive approach, allowing essence and appearance to be understood together? Different philosophical traditions offer different answers, yet each attempts to address the same fundamental question: what does existence truly mean? From this point of view, reflecting on wave-particle duality is not merely an attempt to solve a problem in physics. It also invites us to ask broader questions. How do we understand the world? How do we understand existence? And how can we find a more open and profound perspective that connects concept, experience, and reality? These questions do not end here. On the contrary, they mark the beginning of a much larger exploration. In the episodes ahead, we will continue to explore other mysteries of quantum mechanics while naturally building a bridge between science and philosophy, exploring both their differences and their possible unity, and reflecting on what they may teach us about the universe, about the life, and about our existence. My friends, let us continue to inspire one another and explore these fascinating mysteries together. I will see you in the next episode.